Hi, in this video, we'll be discussing about some more important terminology related to this thermodynamics, like the state and property. See, state will define the condition of the system. It defines the condition of the system. Whereas, if you consider a property, so property defines the state of the system. Property will define the state of system. That means we can say that the property will be in turn defining at what condition the system is existing. Like if you consider a piston cylinder arrangement like this, inside which certain amount of gas is present. So what is the condition of this particular gas if we consider the gas as the system, the thermodynamic system? So that will be defined by the property here. So based on the property, you can say this much pressure is there for this particular gas, temperature is so and so, and volume is so and so. So these properties actually they are classified into two different types. So when it comes to the types of properties, there are two different types: intensive property and extensive property. Intensive property can also be called as an intrinsic property, whereas extensive property can also be called as an extrinsic property. So when it comes to these intensive properties are independent of the size of the system or extent of the system or mass of the system. Intensive properties are independent of the size or mass of the system, whereas extensive properties are dependent on extent or size or mass of the system. So let us see by taking some practical example what is an intensive property, what is an extensive property. Now let us consider there is a vessel like this in which certain amount of gas or a fluid is present. Let us assume that this is a gas. So initial pressure of this particular gas is P, temperature T, and volume is V. Now let me place a thin chamber inside this one. So a thin chamber, if we place inside this one exactly at the middle, then we can consider that here in both the sides of this particular vessel, the pressure will remain the same, the temperature will remain the same, but the volume, as I have placed this exactly at the center, volume may be halved. So that means you can observe from this particular interpretation that pressure and temperature are independent of mass. So therefore, if we take intensive properties, you can write the pressure and temperature are the intensive properties. Whereas if you consider extensive properties, so these are dependent on the size or mass of the system. So in this example, you can see that volume can be considered as an extensive property. See, we know that internal energy is a function of temperature, whereas enthalpy is a function of pressure and temperature. See, the formula for change in internal energy U2 minus U1 is mCV T2 minus T1. See here, if you observe carefully, internal energy is a function of temperature, and if you observe the change in internal energy formula, it is dependent on mass. So therefore, you can consider the internal energy as an extensive property. Similarly, the change in enthalpy H2 minus H1, This will be mcp T2 minus T1. So here the change in enthalpy is depending upon the mass as well as the temperature difference. So enthalpy can also be considered as an extensive property. So try to understand very important thing here: volume, internal energy and enthalpy, these are extensive properties, whereas pressure and temperature are intensive properties. See, any extensive property divided by mass will give an intensive property. For example, you can consider volume by mass, which is specific volume. Internal energy by mass, you take it as small u, specific internal energy, specific internal energy. Enthalpy by mass, this is small h, specific enthalpy. All these specific properties like specific volume, specific internal energy, specific enthalpy, all these are intensive properties. So try to remember about these properties carefully.